So there are video recordings in the classroom, right? So, and I hope you've joined our Telegram groups and everything. Yes, there are video recordings that you can use, and it's as explanatory as possible. We explained some concepts repetitively, so you'll get it. You get, so don't worry. Oh yeah, nobody. Kenneth, you raised up your hand. Yep. Kenneth, you raised up your hand. Is there any other person? Nobody is talking. Oh, oh, yeah. Someone said they got negative. Yeah.
Good evening.
Good evening. Good evening.
Okay. I started the assignment and I ran into some serious issues.
What happened?
Okay, when I was doing the last assignment, during the imaging, I did not get some of the models. So by the time I downloaded the models, my file size increased from 4 gig to about 17 gig, and it freezes my system. So I have to take everything out to a flash drive. I start running on the flash drive, and it keep on crashing. So that's why I ended on the assignment. Then, in course of doing the assignment, I started trying some other data sets that I generated, and I need you to explain the difference between like normalization. There's one called normalization, then there's one called normalization, open bracket, applied.
Okay.
Those are all the difference between those two. Are they going to work in sync?
No, I will explain. Keep asking your question.
Then what? I wrote this down somewhere. Okay. If I see them, I will bring them up.
You are supposed to write it on the table. How did Joshua say it? Yeah. I've forgotten. You're supposed to write it on the table of your heart. All the Bible scholars here tell me. But no problem. I understand. I'm just teasing. I am just teasing you. I understand. No problem. So when you have all those questions, raise up your hand. Let's say because your questions will definitely be other people's questions. And so we can attend to all of them at the same time. Does that make sense? Yeah. A dog. Yes.
Then one other question again. I don't know if you can come across it. Like this date format, say the American format, 2024/month/day. How can I convert it to only the year, to like 2024?
Okay. Work on that. No problem. So date format, no problem. Yes. So Adoga, you raised up your hand.
Yeah, for me, after battling and fighting, I stopped using the what's the name? The regression for text, for categories. I changed to linear regression, and I noticed that I was getting negative. I've been going back and forth. I'm still getting negative. So my R-square is a negative.
So this negative. What do you mean negative? Like
the R-square.
So you use linear regression for the images?
Yes, I changed everything to category to number, and then I normalized it. I used linear regression.
Okay.
And my numeric square showing me a negative.
Oh, okay. That's fine.
Minus 0.911.
I understand. No problem. I would attend to that. No problem.
All right, lovely. Lovely.
Some of you came late. Name of latecomers: number 1, Josephine. Number 2, Adoga. Number 3, Greg. Let me see. Number 4, Emmanuel. Number 5, Bolanle. All of you came. I'm just joking. Right. So back to what we are doing while Greg, you raised up your hand. Let me allow you to talk. Greg. Okay. So back to what we were saying and
hello, boss.
Yes.
Okay. First thing first. Yes, I came late. Sorry for that. Then I have some issues. Oh,
We all have issues. God help us.
God
Mhm.
help us. I have okay, I sent a message on the chat stating that on my other laptop I couldn't download. Every time I download the data set, it comes in as a web page, and I don't know why. But in the office laptop, yes, it downloads as
CSV.
a file. But on my personal laptop, it just
What,
as
what data set are you trying to load?
all. I mean, I'm talking about the housing, the
The
busting
housing,
housing. I'm
the
talking,
diamond,
yes,
the
I'm
adult, everything.
talking
Okay.
yes,
Okay. No problem. And you always go through GitHub, right?
yes,
Yes.
always.
So I'll give you the Kaggle website and try it from there, and let's see.
Okay,
Yeah,
no problem. Thank
no
you very
problem.
much. Thank
Yeah,
you.
you're welcome. Josephine, you raised up your hand. Josephine, you raised up your hand. Okay. So I think we've waited enough.
Sorry. Okay.
Yeah.
Good
You don't know.
evening.
Yeah. Good evening.
Yes, sorry for coming late. And also, working on the data set. I think my accuracy was very low. I think 50 something. And also, when I was trying to increase because I divided the sample into two. So I partitioned it to 50%, and I still partitioned the first 50%. My system started hanging. So maybe the data set was too large for it.
Well,
So that is the issue
did you resize to 0.19?
yes, I did.
Did you try resizing lower and lower?
No, I did not. I didn't try
Okay.
that.
That's fine. We can try that.
Okay. All right.
Bolanle. Bolanle, you raised up your hand. Bolanle. Okay. Bolanle is not talking. Adoga, you can raise up, you can unmute.
Yeah, I resized mine to 0.15 before I was even able to
Yes.
get the system going.
Okay. Okay.
Yeah,
Now,
but I was still getting a negative.
no problem. No problem. All that will be addressed. So now, for all those that are, working towards getting their hands dirty, for all those that are, and practicing, I appreciate it. It's good. Now, the problems you are facing, they are not unusual. You are now moving into the realm of core intelligence training. When we're dealing with numbers, straight up, sharp. Now, you have moved from just numbers to visual. So we are in the realm of computer vision. We're in the realm of computer vision where you take an image as much as possible, as dull as as a non-living thing is, as a computer. They're trying to tell you that this is what a cat looks like, this is what a dog looks like. Right? Now, the accuracy you got using linear regression, that's fine. Linear regression is not appropriate for image recognition. In some cases, you can manipulate as a stopgap, but it's not appropriate. So it's fine as you did it. That's impressive, but it's fine as you are getting negative because why? Those features are too long. So just imagine the image originally is a 150 by 150 by 3 image. Is an RGB image, so it's a 150 by 150 by 3 image. So they will flatten it. When you flatten it, that's 150 times 150, that's 22,500 times 3. So normally your image, the way you've written it, it won't even recognize the 3 channels. It's just 150 times 150. Now imagine a formula that is x1 x1 feature 1, x2 feature 2, x3 to x 22,500 feature x times feature. There's no formula like that. It will probably grow into a matrix and a matrix, something like that. So that is normal. But now we have entered the realm of deep learning. Repeat after me. Deep learning. Again, deep learning. Ìrònú àròjinlẹ̀, like, deep learning. Make sense? So now this is just a tad more complex. Now, the beautiful thing about this class is that where you are now, the stage you are now, you can legit, and that's why I want you to be very intentional about the skill you are getting. Don't waste your 2 hours on Saturday. You can legit watch a movie. You can go and watch, you can legit be watching a movie right now. But I want you to go and read about, what did this guy do? List of folders, part of strings, logistic regression, and use it on. That's why I share my screen, I show you the website we are picking all these data sets from. They are actual data set. That is not me that put it there. You have those skills to work and do those industry standard practices. So let me give you an example. I'm gonna share my screen, my entire screen. Right? And let's just go to pages. And this is a digression. So if I say kegu.com, right? If I say kegu.com and I say, so we've been doing regression. For you to say, let's just say regression, right? But we want to see competitions, right? So these are competitions regarding regression. This is a competition that you can win $50,000. That is actually ongoing. It started 1 month to go, 2 months to go. You understand? And of course, this is crazy, right? This will be crazy. Let's look at their data. I would just want you to know that these are things you can do. So look at the data size. The size of the data is 174 gig. It is split into training, test, and split.csv. It's a CSV data. You can, they have the labels, blah, blah, blah. So it's from the fact that it has labels, it's a classification problem. You understand? Now, these are people that have submitted. This person, his score is 66%. He has submitted 130 times. The last time he submitted was 2 days ago. This is the person now that wants to win, that is on track to win the $50,000. Just imagine we win $50,000. Please, if you can enter it, do you understand? I'm telling you that this is live. So the result is calculated by approximately 35% of the test data. So the way they split it is that 35% goes to test data. The final result, 65% will go, to training. How did this level is calculated by which? With approximately 35% of the test data. The final result is based on 65% of the final standing, blah, 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 whatever they say. Right? This person has submitted a model, right? So all I'm trying to say is the skill you have, right, regarding regression, you are good. You are what? You are good. They've told you, I'm trying to see, it's just that the data is too large. See, so tests is too large. That's why I would have loved to see or look into the data and see what I can do. Right? So, right, it's not, I'm not trying to even, tease everybody, but there are things. This one is just $1. It's just funny. They just want you to learn, right? And you can work as a team. See, customer revenue prediction, right? You can see, right? So that being said, so all this goes back to the different concepts you use. How do you use normalization? Because if you look at the leaderboard, why is it that some people are getting 88%? You can see the 88% gone, plenty is to the highest decimal that they are looking at it to, right? So this was a 6 years ago. These are the top 3 that shared the $50,000 prize, right? So come here, play. You can even do for fun and submit. Even if you are the 200th, voila, it is something. Submit, play, have fun. It's data. The more you play, the more you learn, right? Who follows very dark one here? You learn, right? So Chioma, you are just joining. All of you, I'll be calling all of you out. Chioma, who is there again? Ayobami, Bolanli. So never mind. So let's go into today's class. Let's go into today's class. So I hope I've answered some of your questions. Ogechuku, you raised up your hand. You can talk. Okay. So let's go into that and let's see. All of us that want to win 50,000. Let's be serious. Let's be serious. All of us that want to win 50,000. Let's be serious. So this is the beginning, right? And we did this yesterday. Classification, right? Regression, yes. This, right? And this was your assignment. This was classification continued. This is what we did last week. We talked about. So we are doing a recap. We talked about images, cats and dogs. We talked about, difference between single channel and multi-channel, which is what grayscale and RGB. RGB sometimes can be BGR, it can be RGB, right? We also talked about pixelating of pixels in images, right? If you go zoom down an image to see the pixels, all these pixels are interpreted as numbers between 0 to 255, right? Between 0, black is usually 0, and I think I demonstrated it on the slide by showing you that if we take a text and we want to pick the color, we can go to we can go to we can go to custom, and if you look at this custom, you can see R, you can see G, you can see B. Because everything is zeros, that's why it is black. If I take it to white, everything will be close to 255. If I say red, you can see it's only the red channel that is there, right? If I come to the green spectrum, you can see the green. The green is more black, right? Or most black. If I come to the blue spectrum, you can see the blue, right? So it's usually RGB or BGR, or in some cases it's hexadecimals, right? So no problem. So that was what that slide was about. And then we talked about flattening, which we will revisit again. And we went to 9, and this was the test we did for the assignment. Did some of you go? Wait, hold on. Yes. Let me go and look at your faces. Now, how many of you have gone through all the videos? If you've heard my voice across all the videos, just go to the Q&A chat and say, yes, I have. Yes, I have. Yes, I have. Just go to the Q&A chat. You don't need to unmute. Now, some of you, Tawa Kalitu, you raised up your hand. You can talk. Hello, Tawa. Tawa, are you there? Okay, Tawa is not talking. So, okay. So, now, sorry, before, yes. Okay, we'll come to that. Yeah, okay. So yes, we are here. So deep learning. So we have seen concepts of deep learning, right? In this set of in this course, we have actually touched on deep learning, but we didn't know it was deep learning. So the way we took the images, so normally back in the day, right? This is what used to happen. Let's say they want an algorithm to recognize cancer cells. So what's going to happen is you will now hire a radiologist or a cancer person that went to school to study it. And then they will sit down, they will say, I've looked at 500 cancer cells, and based on what I can observe, a cancer cell of this maturity looks like this, looks like this, looks like this, looks like this, looks like this. So this is stage 4 cancer. Stage 3 cancer cell looks like this, looks like this, looks like this. Stage 2 looks like this. The cavity, the chest, this is, or how would they do cancer? This is lung cancer, nose cancer, skin cancer, whatever. Like, so they will first recognize the type of cancer, the stage of cancer. Like it will be paper, biro, observation kind of things. But with deep learning is now an algorithm that once you show it pictures, you don't need an expert to be beside you. You show it pictures and it will be able to identify what makes a cat, what makes a dog, without, so to know that a cat has, the dogs have whiskers, but a cat is more feline. This is how cat is. The algorithm in itself will be able to make that selection without the need of somebody being by their side or a supervisor. Do you understand what I mean? Am I making sense? Okay. Nobody's talking. I'm assuming that means I'm doing a good job, right? So now, AI as a whole is devoted to making human beings think, machines think like human beings. That's the goal. Now, machine learning is focused on enabling computers perform tasks without you programming it. You get, is to say, oh, do this task without you programming it. Right? Just give me 1 minute. Right? Is the ability, is machine learning is focus where computer, without telling it what to do, it can do the task. Oh, tell me if if these people are rich or poor. Tell me if it can do that. Now, deep learning is based on artificial neural network, right? Where they can think. So neural network is type of like, we are trying to mimic the brain of a human being. We're trying to mimic the brain of a human being. And this deep learning has now subdivided into transformers, into LLMs, all those ChatGPT. These are the foundations of what they do. Now, deep learning has different layers. From the input image, like we've seen, we can do convolution. Now, what you should ask me is, what is the meaning of convolution? What does convolution mean? Now, in literal terms, for all those that know how to cook and all those that have cooked, right? Convolution is like a sieve. It's like a sieve. So when you are doing moi moi, or when you are doing, pap, ogi, you understand? For those that are not Nigerians, pap is like grinded corn, right? And then you liquefy it. Is that in carbs? So now when you want to get the nutrients, what you need, when you want to get it, what you pass it through a sieve. That is what convolution is doing. Convolution is a mathematical algorithm that is used as a filter to filter features common in the data set. So if I say cat, 1,000 cat images, it is going to look at this image. This is what everything looks like. When it comes back again, these are the similarities. These are the similarities. These are the similarities. By the time it gets through like maybe 50, 60 images, this is a cat. But then it will generate its loss for you, and you say, oh, this is what it thinks is a cat. If it is wrong, you have to change your data set or your algorithm. Now, pooling layer, we're still going to talk about them in details. Pooling layer is a subsampling layer. Pooling layer was invented to help us save processing power. We're going to look at it. Pooling has its advantage. It has more advantage, but it also has its disadvantage. And flattening, we've discussed flattening, where you have a 2D matrix that is made into a one array vector. Now let's go into convolution. Like I said, convolution is a filter. Convolution is the process, convolution is the process of filtering. Convolution is the process of filtering. Now, if you want to perform filtration, what do you need? you need a filter, and that's what we have here. You need a filter, and then you have your waste and your output, right? Now, in this convolution algorithm, we have a 3x3 filter. We can have a 3x3 filter, a 2x2 filter. It's usually odd numbers. Hey, I think I'm talking too much. Let me not drag everybody down. Anjorin, are you there? Okay. Anjorin, can you unmute? Anjorin, please unmute. Say something.
Yes, I'm following.
You understand?
When you are talking about, yes, I'm following. It's making a lot of sense. The convolution and filtering process.
Tell me the last two. Tell me something shocking about some of what I've said. Tell me.
Yes, you are explaining convolution, how, and you use an analogy of a filter, and you mentioned the material, that's the waste, you call it waste, the filter, and of course the output. That's where I followed it to. But when you are trying to say something, you are trying to relate it to, you mentioned PAP, local PAP. I think you are trying to use it to describe a filtration process.
Yes.
I was saying custard in my mind, but no, I think it wouldn't work with custard. Custard is already filtered.
Don't worry. From the next, when I'm explaining now, I will be using moi moi bean cake. Now, don't worry.
Okay.
It's fine.
All right.
Yes, let's look for another. And join pass the test. Damilola Omotere, are you there? Damilola, can you unmute? Damilola wants to ghost me. Okay. It's fine. Ogechuku. Oge, are you there? Ogechuku, if you are there, unmute yourself. Someone is raising up their hands. Okay. Nobody's there. If who is there that can, I hope I'm not confusing you, please. This is the basis, this is the foundation of this concept, and such that you are not lost. We can go to 9 and I'll say drag this to drag this to drag this to. You need to know a bit of the theory, so when you are faced with a problem, you know where to tackle it from. Is it my filtration that is bad? Do I need a bigger filter, a smaller filter? Okay, is it my pooling that is back? Should I use max pooling or average pooling? This is what makes a very good machine learning engineer outstanding, and a very average machine learning engineer average. Right? Damilola, are you there? So please, I know some of you, as I'm talking this thing and background noise, some of you are eating Gary, some of you are watching Premier League. Please, just pay attention. Whatever you are doing, do, but just pay attention. Yes, Damilola. Abiu is talking.
Yes, Damilola.
Damilola, why did you leave your system? You did not.
No, I didn't. I couldn't unmute until I raised my hand.
Yes, now that's what I was like. Raise up your hand now.
Okay.
I need to have faith that you are listening to me. It's not.
No, I'm listening.
Do you understand everything I've said about convolution?
I do.
You do.
I do about the filtering, PAP, convolution.
Yes.
Yeah. I'm following.
All of you like food. It's PAP. PAP like also. All of you like Ogia, no problem. But irrespective, right? I see. What is paining me so far is that none of you have reached out on the group to say, doctor, this is my resume. I was looking at this and I think I can apply for this job. Because you've not practiced, because your confidence is not as high that people can. You need to get this skill within yourself, in yourself, that someone can pay me to do this thing for them. You understand? That's why I'm showing you that regression is out there. You need to get it to yourself. I want from next week, because we're already getting to the core place, right? In my job, for what I do, I don't use some of these skills. Right? If with some of the skills I've taught you, right, I can hire an intern or an associate that can do my job. So far, I just give them some tips. Right? So I want some of you to be like, I saw this job. I looked at this job title. Doctor, you've not taught us this. You've not taught us this. Yeah, I can do this job like this. You understand? If you're whining, it's fine. It's okay. God help us. Ayobami, raise up your hand. Ayobami. Okay. So I'm not going to take any questions up until I finish the concept. Yeah. Ayobami.
Good evening, sir. My question is this process, conflation, pooling, are there steps that we take in I want to do deep learning, or how does it come in? How does all this
I'm going to explain everything.
now?
No problem. Right. So I'm glad that we are following. The little exercise was so that I'm not talking to myself, right? So I will go back and then we'll continue. So yeah, convolution. Convolution is the process of filtration. Convolution is the process of filtration. Please pay attention. Convolution is the most important layer. In short, it's because they invented convolution. That's why there's deep learning. Other layers are important too, but it's important. And because convolution layer is missing, that's why that cat and dog, linear regression is giving us negative. Convolution will have filtered what is useful. Linear regression is creating weights for what is useful and what is useless. And hence, it's confusing the model at the end. But convolution will be like, kilele now, stop it. What's this? Get away. This. By the time you get it to some layers, it's just going to be maybe 8 numbers, and it will be useful numbers. Right? There's even something called early stopping. In training, if you have created a layer, sometimes after the first or second convolution layer, you can be able to successfully identify stuff. It's called early stopping. So maybe you created a 16-layer image because you were afraid, let me create a model that has 16 layers. And after the first convolution, your loss is very small. Second convolution, your loss is very small. Very small. You can just say early stopping. You know what? If my loss is between this range, stop here. Let me just divert. Still continue. Let me compare what is at the second layer. Convolution is that powerful. And what does convolution do? Convolution is the art of what? Filtering. For you to filter, for you to perform filtration, you need a filter. Those filters are usually called filters or kernels. They are called kernels. Kernel. So in some places, you can see filters, you can see kernel. Now, let me give you an example. Now, in some cases also, they can be, they can receive the same image. You can now use different filters. You can use different filters to go through the same inputs. We go through different filters and we produce different outputs that we will mesh together. So look at this example. In this example, right, we have a 3x3 kernel. Now we have a 3x3 filter. Now, what would that filter do? You will just paste it on your image. Like now, this is 021410101. This is the filter. Now, this image is a 1, 2, 3, 4, 5. Is a 5x5 image. Is a 5x5 image, right? So these 3 metrics will go on the first 3. You can see the print. It will now be 9 times 0 plus 4 times 2 plus 1 times 1 plus 1 times 4. If you see it, 9 times 0 plus 4 times 2 plus 1 times 4 plus 1 times plus 1 times 4. I think they went like this. 941. Then there's 410 and there's 101. They took it somewhere, but once you get it, you can see that it has blended all these features. All these features. into one number. It has merged all the attributes of that features into one number. So, like your computer now, you can see when you gave it the old image, it was crashing. It's crashing because it's dealing with 150 by 150 by 3 images. But convolution, the first thing convolution will do is it will first filter the useless. It will shrink it down, it will subsample, and it will bring it to what? One number. So if you see, this is 5 by 5, it is going to end up to a what? A 3 by 3. A 3 by 3 matrix. Am I making sense? So if you want to do it, after we do this one, we are now going to move this thing. We're going to move it to the next stage again. It will be 0 times 4. You know, it started from 911. The next one, we will move the filter by 1. When we move it by 1, it's going to be what? 4 times 1 times 2. Don't worry, I will explain it to you in the other slide. Now the act also, this is 6 by 6 by 3 inputs. Now in this case, they gave it 2 filters. So this image will come to this filter, right, and produce an output. This image will pass through this filter and produce an output. Do you understand? So there are situations where there can be more than one filter. Now the number of filters per filter, the number of channels per filter is equal to the number of channels of the image. In this situation, the image has 1 channel. So the filter has 1 channel. In this situation, the image has 3 channels. You can see each filter has how many channels? 3 channels. Am I making sense? Please. Nobody's raising up their hand. What makes sense? What makes sense? Damilola, you raised up your hand. Josephine. And John, all those. Tawa Kali too. You raised up your hand. If you raised up your hand, Josephine. Annie.
The channels, I mean channels, Twitter, that's 3 channel. I'm looking at the image there. I cannot see any. It's 3 by 3. This year I'm saying, where is the channels from? Like, what's a channel?
You can see something that is red, something that is green, and something that is blue, right? RGB channels. You can see the input image is RGB. Abi?
Yes.
Because it's RGB, that means it is a colored image. It's a 3-channeled image. Now, if you want to filter a 3-channeled image, your filter has to have how many channels? 3 channels. If you look at the color, 1 filter for the red channel, 1 filter for the blue channel, 1 filter for the what? Green channel. Sorry, me.
Yes, sir.
I'm making sense, Abi?
Yes, sir.
Thank you. Any other questions? Damilola, you raised up your hand.
Sir.
Yes.
Okay.
Who raised up? Somebody raised up their hand.
Damilola last minute. Sorry, sir.
Yeah.
Can you, please, sir, can you come with that last statement? You said the number of channels per filter is equal to what?
The number of channels, if I was writing by chapter 1, verse 1, the number of channels per input.
Okay, per input, okay.
To the number of channels per filter. So if you look at the image now, the filter has 3 channels. The input has 3 channels. Make sense? That's the only way you can get one image. So if you look at, they gave us a 6 by 6 by 3. They gave us a 6 by 6 by 3. They convolved it with a 3 by 3 by 3 to get a 4 by 4. That is 1. They now did it again with another one to get another 4 by 4. So the output channel is 4 by 4 by 2.
Okay.
Please, this slide is heavy. When I wanted to understand it, it took me a week of looking at the same thing every day. That's why I know that you're supposed to have questions. Number 1, what are you supposed to ask me? Why is it 4 by 4 by 2? No, but since you did not ask me, I'm not going to answer it. Since you did not ask me, I'm not going to answer it. Second thing, how the 6 by 6 by 3 convolve with 3 by 3 by 3 to just give 4 by 4. Where's the channel, the third channel? Nobody's answering. Okay. Nobody's asking. No problem. Eshe. Thank you. Let's move on.
Water is passing Gary.
Eh?
Water is passing Gary.
Good. So these are questions that, you know, yes, Josephine.
So we were getting there. We small. We were getting to those questions. We actually getting there.
You're not there early.
So it's
I'm
like,
going to bus stop. Huh?
so no, we cannot close it though, because this thing is confusing. We are going to get there.
So just like the word says, convolution. The knowledge is actually convolving, right?
Okay.
I want you to pay attention. Now let's go back to the left image. In the left image, there's one input. Now, because there's one input, there's one filter. No. There's one input that has one channel. So there's difference between quantity of channel and quantity of input. There's difference between channel and quantity. Pay attention. There's difference between channel and quantity. Now, in the first input, in the first image, the one that is gray, there is one image that has one channel. Now, it is convolved with a filter that we have automatically one channel because the image has one channel. Doesn't make sense. Now, how many filters do we have? We have only one filter there. That's why we have one output. The number of outputs is the number of filters. The channel of the filter is the channel of the input. Now it will make sense now. I know all of you are like, it will make sense now. Let me go to the second image. Let's go to the second image. How many images do we have? We have one image. One image. How many channels do we have? We have 3 channels. Hope I'm recording this thing. Okay. We have what? 3 channels. Abi, red, green, and blue. Now, because we have 3 channels, God should just bless somebody now. How many channels of filter are we going to have?
Three too.
We have 3. We are going to have 3 because the input has 3 channels.
Yeah.
You understand? Look at the first one. Look at the similarities. In the first image, the input was 1 channel, and the filter was 1 channel.
Yes.
In the second one, the input has 3 channels. That's why the filter has 3 channels.
Yes.
Very good. Very good. Now, because it has 3 channels, if you look at the first one, how many outputs do we have? We have 1 output. Why? Because how many filters do we have? 1 filter.
1.
Look at the second one. How many outputs do we have? We have 2 outputs. Because how many filters do we have?
Second one.
We have 2 filters. Does that make sense? The number of outputs is the number of filters. The number of channel of the filters is the number of the channels of the input. So you see how output relates to filter, filter relates to input. Make sense? Am I making sense?
Yes.
Good.
Wait, too.
Yes.
Can you hear me?
Yes, I can hear you.
Okay. So you said the number of the number of channels of inputs is equal to the number of filters.
Me?
Right?
No. I said the number of the channel of the input is equal to the number of the channel of the filters.
Number of channels of the filter. Okay.
If the input has 3 filters, 3 channels, automatically your filter has to have
3 channels. Okay.
Now, but you can have multiple filters. Like this one, they have 2 filters. You can have 10, you can have 15.
Okay.
So that means that the number of outputs, so you can see your output is 4 by 4 by 2. In that situation, if you have 16 channels, it will be 4 by 4 by 16.
Okay.
Does that make sense? I want you to understand this before I go to the formula below.
Okay.
Makes sense. Some people are raising
Yeah,
up
it
their.
makes sense, but how do you know how many filters to bring out?
Oh no, that's up to you. That's your design. That's
Okay, that's my design.
That's your design. So you can choose to have something that has 15 channels. We're going to go there and we're going to design our own convolution. You understand? That's what will make the model different from another person's model. If you look at those results we said, some people had 88%. All those little design is what makes their model different from each other.
Okay.
Josephine.
So how did we get the 4x4?
Oh, we
Like-
will get there. First, understand the last number. You understand in the input image? Do you understand the by 3? Yes, it has 3 channels. Now, because the input has 3 channels, all the filters will be by 3, the last 3, because all of them have 3 channels. But now, because the filter is 2, you can see the output is what? By 2. That last one does understand it. Do you understand it? If you understand it, that one is fine. Some people are raising up their hand. Sumbo on mute. Samuel Odusanya, you can talk. Tawa Kali too, you can unmute. Okay, since there's nobody. Oh, yes,
I'm talking. Good evening, sir. Good evening, sir. This is our Khalid Adewi.
Are you not? Is it Khalid or Khalid too?
Our Khalid. I've been raising up hands since the beginning of this lecture.
Tawa now.
Sir, I'm sorry, but everything just look like magic to me.
I'm a magician.
Maybe
I'm a magician. Continue.
Maybe because joining the class today. I'm sorry, can you please simplify all your talks? Like, what is the input, what is the filter, what is the output? As in, I'm just getting confused. Oh, I'm understanding what you are saying, but all these input filters, everything is just looking like magic. Is there anything you can just recommend for me? Probably I should just go to school and join the class. I don't know. I'm sorry for asking this.
You are fine. So, in my secondary school, there's a friend I used to have. Her name was Tawa Kalitu. We call her Tawa, right? And that's why I was like Tawa Kalitu. Tawa, where are you based? Are you based in Lagos? Where?
No, I based in Ibadan.
Ibadan.
Yes.
How far are you from UI?
Not that far.
Not that far. There's a Sky Amala. I don't know if you know Sky Amala. I don't know.
Sky Amala is Bodija.
It's Bodija. Yeah. That's I'm actually back Batakere, So now today is your first time in class, right? But now it may be confusing, but that's fine. I'm going to drop the link to the classroom so you can join and see all the previous videos. Please make sure you watch it before the next one. But today is also the first time I am teaching this class. So your confusion is everybody's confusion. I'm also confused.
Wow.
Your confusion is everybody's confusion. Don't worry,
confused.
That is why I'm here. That is why I'm here to clear it. To clear it hands down. But you have to ask questions. You have to interact with me. You understand? Yeah? Don't worry. Tawa used to cook ogi now. You used to cook ogi. Woman say moi now.
Yeah, of course, yes.
Okay. Now,
that's what I understand, but as in the concept, like this revolution layer, what are we using it for?
You are using it to filter. You are using it to filter. When you want to do the memory, after you remove the back, what say now? You will remove the shaft. From the pins. Right? That process, remove. Someone should mute or the process of removing what you need, what you don't need, is called convolution. Now, if you look at the first image, the matrix is 5 by 5. If you look at it, reduced to what? 3 by 3. They have removed some useless things. 3 by 3. If you look at the second one, it was 6 by 6 by 3 that
By
became
6 by 3.
4 by 2. It removes some useless things. Now it's that 4 by 4 by 2 that they will take and go and put in the blender, and they will blend so that they can use it in that way for the moi moi. Am I making sense?
And all this, is it that you've had one class before that all this evolution, or they are used for, maybe they are used to generate something? That is where I'm confused.
Tower, don't worry. Let's finish the class. You will see. And you will see if your
Okay.
confusion is there. Let's finish. Don't worry.
All right, sir.
Sumbo, where are you?
Okay, I'm here. Can you hear me, sir?
Sumbo, wait first. I have a beef with you.
Yeah,
From the
I know.
last time I told you, you said your name. You missed all the classes. I wrote your name.
Yes.
Put it down. Don't worry.
I'm sorry.
Question.
Something came up. I actually went back to the videos and I've watched one of the classes I missed.
Mm-hmm.
Yes, the question I wanted to ask, I think
your assignment.
No, I didn't do the assignment. I've not done it.
Okay. So
I'll
your
do
question.
So the question. Okay, yeah. So my question, I think Josephine asked the same question. How did you get? Because from the input we have like 6 by 6, then it became the filter is 3 by 3.
Mm-hmm.
Then the output we have
it's
4 by 4. Yes.
I'm going to explain by 4 number. That's the simplest part.
Okay.
That's the simplest part.
Okay.
Samuel.
All right, sir. I believe you can hear me, sir.
Yes. I believe.
Okay. All right. My question is the choice of the number of filter. Like in this second diagram, there is filter 1 and filter 2. Is it possible to have filter 3 also?
Yes. That's design choice. And that's what we stand your model out from someone else's model. So I can decide to do the same thing with 5 filters. Someone can do it in 16 filters, right? And we can get comparative close accuracy or different accuracies. If you see at the start of the class, when I was showing you different people and their results, it's just design choice. So these are called hyperparameters. Hyperparameters is left to the engineer to do. Do you understand? It's left to the engineer to do. So there's no standard that automatically when you see cats, put 2 filter, and you bell. You understand? So you want to cram it for everything? No, it's design choice. But you have to experiment iteratively, right?
All right. So another question is for the filter, here we have 3 by 3 by 3. So I know that for each channel, like for the G, it is 3 by 3. Okay, for R is 3 by 3, and then for
no.
Okay.
So what it is RGB?
Yes.
Plus the filter now has RGB. So for each channel is 1 to 1. You understand?
Okay. So is it because it is RGB? That's why it is 3 by 3.
That's why it is 3 by 3 by 3. That last 3. Yes.
Okay.
That's why
your what about the first 2 threes?
I'm going to get there. The first 2 numbers we've not gotten there. I've only explained the last number. I'm going to get there. Right. No problem. And when we get to time, yes.
Yes, I have a question.
Yes. So
when you explain the grayscale to I don't know who you explain it to, but it said the output is 3 by 3. But I thought the output is just 1. Like that's 16.
I told you that grayscale is 1 channel. The first image on the left is 1 channel. That's why it has 1. That's why the filter has how many channels? 1 channel. The second one is what? RGB. That's why the channels have 3 channels. Now, why I want you to understand this is this. Why I want you to understand this. This is the test that I can teach you this concept very well. Now, let's assume that the second image, I used 7 filters. What would be, how many channels will the output have?
7.
It will have 7.
7, yeah.
God, because only wallets me, I will have sprayed you money. We would have 7 filters, right? 7 filters. So that means output, the shape of the output to be 4 by 4 by what? By what?
By 7.
By 7.
7 by 7.
Now, let's cancel everything in front. Let's take that as an input to another layer. The output of that is what? 4 by 4 by 7. How many channels will the filter to that output be?
7 also.
Eh?
It will be 7
Once
also.
it's made.
7. So I can create another 3 by 3 by 7. It will be 3 by 3 by what? 7. So I don't want to restrict your mind that the number of channels has to be 3. No, it can be any number based on the number of channels of the input. Am I making sense?
Lots of sense, sir.
Lots of makes sense. I'm happy we already understand that channel thing. Before I understood it, it took me a while. So I'm happy that I can convey it. So let's move on to the other 2 numbers. The other 2 numbers have a formula. What's the formula? N plus 2p minus k over s plus 1. Oton. The number has a formula. N plus 2p minus k over s plus 1. Oton. That's it. The other 2 numbers. So let's take 6 and 3. Let's take 6 and 3. Now, the first n is the number of the input image. So in that scenario, it is 6. Oh, your input is 6. 6. Your second n, your k is kernel. In this place, they use k. K is kernel, right? K is kernel. And k is what? 3. So 6 minus 3. Your s is stride over 1. 6 minus 3. Your p is 0. Padding. We'll go to padding. 6 minus 3 over 1 plus 1 is what? 4. And that's how they got 4 by 4. Making sense?
Come again, sir. Come again.
In these examples, P is 0, S is 1. P is 0, S is 1. P is 0, S is 1. I will explain it. In this example, P is 0, S is 1. But the number of inputs is, your input is usually a square metric. So 6 by 6. So just take the 6. The number of your kernel is 3. So 6 minus 3 over 1 plus 1. That's 4. 4 by 4. If you look at the first image, your first image is 5. Your kernel is 3. Right? It's going to be 5 minus 3 over 1 plus 1. 5 minus 3 is what? 2. 2 over 1 is what? 2. Plus 1, 3. That's why your output is what? 3 by 3.
What if the image wasn't square?
Eh?
What if the image wasn't square?
Make sure it's square. They won't. No, but so what we usually do in practice is we shrink it down to a square. Do you understand? We shrink it down to a square. Now, I've dealt with images that were not square, right? In practice, it is better if they are square. In practice, by standard, it's better if they are square. I've dealt with images that are not square. There's a way you can do the calculation, but I don't want to complicate it. Do you understand?
Hello, sir.
Yes, please. Great.
Hello, sir.
Yes.
Yeah. The P, that's the padding. Is it 0? Is it constant 0?
In this example, it is 0. We are going to go to padding in the next slide. In this example, it's 0.
Okay. All right, cool.
So thank God that we are done with this slide. Any questions? Anna Duncan used to miss our class. Anna, it's been a while we saw you. Anna, please raise up your hand. Let's talk. Okay. Josephine, you raised up your hand.
Hello, sir.
Yes.
Sir, sorry, this is Greg again. Okay. You said in this situation it is 0. That's the P padding. How is that, sir?
No, we'll go to the place where it's not 0, so you can see it.
Okay.
Don't worry. Just Ogechuku, you raised up your hand. Adoga, you raised up your hand. All the people with their hands raised.
I missed how you got the convolution kernel size. That's the K.
Oh, kernel size, the K, because in this example it is 3 by 3. That's why it's 3. K is 3. In this example, the image size is 6. Kernel size is 3. If you subtract it and do that, use that formula, you will know how we got the 4x4. Right? So
hello.
Yes.
Hello. Yeah. So what about this? The n is it subscript? I mean,
N subscript in, right, is the number of your input size. So in this case, your input size is 6x6. So that's why it's 6.
Okay, so 6 plus. So 2 times 0 is 0.
Bam.
Is that what you're saying?
Yes. 6 minus 3 divided by 1 plus 1. Shikina.
Yes, it's 4.
Bam.
Okay.
Sorry, sir.
Josephine, yes.
Yes, sorry, I went up when you were explaining the equation. So please, what's stride size? My network kicked me out, so I had network issues.
The stride size is what?
The S part of the equation.
The S part of the equation is 1. I'm coming.
Sorry, sir, is this formula okay? So is the S and P and K all constant? Like their values, are they always 1, 0?
No. They are
Okay.
not 1, 0.
So how do you investigate or detect that during all these
so
inputs and all that?
Just give me 1 minute. How do we detect? Good message. Good question. Some of them are based on design choice. Some of them that based on one design, everything is automatic. So let me give you an example. Imagine my image is 150 by 150 by 3. Without any thinking, how many channels will my filter be? My image is 150 by 150 by 3. Without any thinking, without me doing anything, what do I already know as my channel size?
3.
It's 3. Am I making sense? Who did not understand what I said? Who does not understand the concept of what I mentioned? Does everybody understand? People are raising up their hand.
I did not understand that concept, though, but I understand the formula you talked about.
Hold on. This one has nothing to do with the formula. This answer has nothing to do with the formula. Okay. You know, if you look at the image, let me just go over it again. Let's take the first image. It is a one-dimensional matrix, right? It is the one with the 941. If you count it, it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's a 5x5 image, right? Now that matrix, how many channels does it have?
Please, where is the 5x5? I can't see.
So if you look at the image, there's a 94122, right? That line, if you count all the numbers in a line, that's what 5.
The image at the extreme left.
Yes, it is 5.
Is it 4?
Huh?
Which one is that? Which one is that?
So if
The
you
one in the gray part.
The image at the extreme left.
If you look at this, it's a matrix, right? I cannot see. My mouse is not showing. Okay. If you look at this is a matrix of 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Hence, this is a 5x5 matrix. This is a 5x5 matrix. Anna, do you understand me?
So I've been trying to understand them.
No,
Okay, so
yes.
Yeah, I get it. So you are counting the top to your L shape down?
No, it can. So if you look at it, just look at it. This is a square. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You can count it from anywhere. It is the length. Okay, the length is 5. The breadth is 5. That's why it's a square.
Okay, I think I'll
I understand why it's a 5 by 5 matrix.
Problem. Now, if you look at it, there's only one of it. It has only one channel. What type of image is it? It's a grayscale image. Because it has only one image, one channel, our filter automatically has how many channels?
One.
One. Thank you. So without doing any calculation, some of your decisions will have already affected your whole system. Now, if you go to the second image, if you go to the second image, now the input has 3 channels. If you see that matrix, the matrix is 6 by 6. But if you look at, there are 3 of them. So there are 3 channels. Automatically, your filter already is going to be how many channels? 3 channels.
Great, yeah.
Making sense?
Yes.
Okay, very good. Now, what are the things that is design choice? Now, Anna can come and say, for my own work, I want to use 5 channels. Because Anna has used 5 channels, the number of outputs she will have will be 5. But Josephine will say, Emike, 5K. 5 is not my favorite number. My favorite number is 7. She uses 7 channels. The number of outputs will be 7. Am I making sense? So there's no standard to say, is it a constant? K is constant. No. The number of channels, right? Now, in my own case, my channel, in this case, the channel is 3 by 3. In my own case, I can decide to use 7 by 7, 4 by 4, 8 by 8. All those things are design choices. And I want us to wait when I demonstrate it in 9. Make sense? We'll demonstrate it. Yeah. So let's move to the next concept. Now, this is just an example of what convolution looks like. Right?
Please, I have a question.
What's the question?
So, the filter.
Yes.
I noticed that it's 3 by 3. Okay. Does it mean that filter is always 3 by 3?
No. Like I said, it's design choice. You can choose to make your filter 5 by 5. We are going to see examples. In this scenario, 3 by 3, but you can make it anything you want. Now, this is an example of how filtration happens. This is a filter. Now, if you look at the top, they said the padding is 1. I will tell you why the padding is 1, but I just want you to see figuratively how it is. Now, this image has 3 channels. Channel 0, channel 1, channel 2. Now, because it has 3 channels, the filter already automatically has how many channels? 3 channels. And that's what they've given us. And W0, W1, and W2. Am I making sense? But they did it with 2 filters. The number of filters they used was 2. So that means the number of filters we will have is what? The number of outputs we will have is 2. Am I making sense?
Yes.
Yes. So you can see we have filter W0 and we have filter W1. So sometimes it can be filter, it can be kernels, it can be weights. They can call it filter, kernels, or weights. That's why they are using W here. Right? So do you understand? Does it make sense? Any questions? This is just a visual representation of how convolution works. We are shrinking the image and keeping the most, the most important features. That is what we are doing. So if you look at this 7 by 7 image by 3 was reduced to a 3 by 3 by 2 image, because we are trying to get what is important, what is unique, what is similar. Hello? Any questions? Very good. Now let's go to padding. What does padding mean? And why was that padding? Oh, what's your question?
Yes, you said this the image has 3 channels.
Yes.
But the filter also has 3 channels. But all I'm seeing the filter is W0 and W1. Where is the third?
See it now.
Channel?
You can see it. So W0, this is the first image, W1. But if you look at this W0, if you look at the last digit of it, it has 0, it has 1, it has 2. Those are the three channels, 0, 1, 2. If you look at the W1, it has 0, 1, 2. Those are the three channels. So if you look at W0, it is 3 by 3 by 3. W12 is 3 by 3 by 3. Am I making sense? Hello. Okay. No problem. So now, what does padding mean? Now, I want to explain something about convolution to you. If you look at this convolution right here, now, if you notice, every center image centered to the kernel, that's the pretty girl in the room. That's the girl we all want to toast. That's the girl. For every convolution, for every instance you use the kernel, that's the person at the center. That's the person everybody wants to toast. Right? That's the person we want to impress because it's about them. At that moment, when we are doing that convolution, it's about them. That's the most critical thing. We want to see if they are important or not. So let me give what do I mean? Now, if I take that image, that kernel, if I take this kernel here and I place it on this image here, I place this kernel, I place it on this image. One is at the center. The best way to do it is one is at the center of everything, right? Now, we want a situation where, now, if you look at it, there's no way 9 or 1 or 2, all the ones at the edges, there's no way they can ever be at the center where they are the most, everything is gravitating around them or it's about them. So what we use padding for, so that we don't lose information about the image. In this scenario now, if you look at padding, the image in itself is the image in between. If you look at it, is now surrounded by zeros. It is surrounded by zeros. If you look at all the channels, it is surrounded by zeros. Why is it surrounded by zeros? So that the first image at the edge, without the zeros, we can make it at the center. We can get as much information from it at the center. Am I making sense? Hello. So the concept of convolution is that we want to focus on the number at the center. We want to focus on the number at the center. In this scenario now, from this image, the number we are focusing on is the one in the middle. Is the one in the middle, right? Am I making sense? The one below the 4 in the middle. That's what we focus on. Right? Now, if we yes, who is talking? Yes.
Yes, Anjori is talking. I guess is this image that you are talking about, that the one we have inputs?
Yeah, the one that is 941 111 121. Yes, the one at the edge.
Okay, the one at the edge. Okay. So, sir, which number in this image now we use is the one at the center that we are focusing on?
Which one is number one?
I'm seeing one.
It is 3 by 3, Abby. Which number is in the middle of the image, not of the filter? The filter is, we don't need the filter.
Of the entire image, the colored one.
The colored one. When we move the filter again, when we move the filter to the right, you understand? It will be another one. So this, at every point in time, based on the kernel, there's a number at the center. There's a number at the center of the filter. There's a number at the center of the filter.
Yes. So if we move the filter to the right now, it will become 0.
If we move the filter to the right, it will become 0. That will be the next number we are focusing on.
Yes.
But with the way it is, that means that the 9 on top can never be at the center.
Yes, correct.
4 can never be at the center.
No.
1 can never be at the center. 2 can never be at the center. So we don't know if we are losing vital information. We don't know if we are losing vital information. So maybe we want to take an image and check cat and dog. And some of you that don't know how to photograph, you don't know how to take picture. You now take the picture. The picture is now at the edge. The picture of that cat and dog is at the edge. right? What if we're losing that information from the image? That is what I'm attending, and what will pad it. So in this scenario, if you notice, they padded it, they put zeros across every side of the image. The image originally was 5 by 5. The image originally was 5 by 5. If you see, the image is 0, 0, 1, 0, 2, 0, 1, 1. It was 5 by 5. But they put pad across everything so that if you look at these boxes, these kernels as they are moving, right? If you look at the first 0, every number is at the center. Am I making sense? With this one, every number will be at the center.
Okay, I think I'm getting it now.
So that every number will focus, and if case we are losing any information, we can get it. In case an information is concentrated at the edge, we can get it. That's why there's padding there. In all these other ones, they did not pad. There's no 0 across all of them. Because there's no 0 across all of them, you understand? Padding is what? 0. That's why P is 0.
Okay.
Right?
Yes.
You understand? So, but in all this, we want to check if there's information on the edge. Now, let's assume this kernel size is 3 by 3. That's why padding is 1. If it was 5 by 5, padding will be, if you put 2 padding, look at, you can see padding is 1 because we want to use a 3 by 3 kernel. Because with 3 by 3, the edge will always be at the center. If your kernel was 5 by 5, your padding will be 2. Am I making sense?
Sorry, sir.
Imagine this matrix, this weight matrix was 5 by 5. Imagine it was 5 by 5. You know, if you put it on that edge, can I pause this thing? You know, if you put it on that edge, part of the 5 will go out of bounds. You know, this matrix now is 3 by 3. Let me show you.
Yes.
Let me do this. Convolution, padding 2. Oh. Wait. Padding of 2 is not commercial. Yes. Yeah. Sorry.
Sometimes deep learning can be a bit abstract. That's
Yes,
why.
it is.
God, like abstract is.
Look at
You have to relate it to things around me before I get the gist.
now. Look at this, right? This is padding of 2. This is padding of 2. Now it's padding of 2. Why? Because if I'm putting it at this edge, if it was 5 by 5, 5 by 5, you know, this would be 1, 2, 3, 4, 5. Like the kernel is a square matrix. It has to, for it to touch everything, the kernel has to be 5 by 5. If it is 3 by 3, we just need 1 padding. Right? We just need 1 padding if it's 3 by 3. But 5 by 5, we will need another one so that the kernel will not go out of bounds. Right? So look at it. Very good. This is beautiful. So this is the image. Right? This is the image. This is, where is it? Diary. So this is the Ebony, where is padding? So this is the image, and they padded it 2 times, right? They padded it 2 times so that what? In case the kernel is what? 5 by 5. You can see it. So P is 2. So the dimension was increased from 5 by 5 to 9 by 9. And now that we know, so the formula is what? W minus K plus 2P over S plus 1, which you already know, right? So you know what? I want you guys to dwell on it more so we can, where am I? So we can move to this. Pooling is a younger brother to convolution. Is a younger brother, but it's not as complex. Pooling is like, who is the best among you? Convolution, you are doing multiplication, addition, subtraction to get the best, most most generalized definition of everything happening in that area. So that's what convolution is doing. Convolution has told me that there was 9, there was 4, there was 1, there was 1, there was 2, everything 16. It's getting the best, most generalized definition in that area. But what does pooling do? Pooling just picks the best, most prominent feature. So if you look at max pooling we look at, so the pooling also has a filter. But instead of the filter to compute, pooling will just, like I said, pick the best feature. In this scenario now, there are 2 types of pooling: max pooling and average pooling. In max pooling, they said 9, 4, 5, 6. What did he pick? He just picked 9 because 9 is the largest number. Because 9 is the largest number. In this case, 5, 2, 2, 4. He picked 5 because 5 is the largest number. Max pooling, in an area, we pick only the highest number. 2, 4, 5, 6. He picked 6. 5, 4, 8, 4. He picked 8. Am I making sense? Am I making sense? And Johnny, you're making noise. Oh. Annie. Adoga, you raised up.
Yeah, so in this pooling, must it be 2 by 2?
No, it can be 4. It can be any. In that area, it's design choice. In that area,
design choice again. Okay.
Understand? You should just pick
Yes.
it. If you want, so now pooling is called subsampling. If you notice, we are just picking. We are not computing. We are not, unlike convolution, we are computing. Do you understand? So there's average pooling. What average pooling we do is it will take 9 plus 4. It will calculate everything and find the average. It calculate everything and find the average. It calculate everything and find the average. By standard choice, people have noticed that max pooling is better than average pooling. People have noticed that what max pooling is better than average pooling. Dropout layer. Dropout layer. What does dropout layer mean? Dropout layer is that when you are training, maybe for example, this is a 50. This is 50 by 50. You have already flattened it. It is convolving to a 20 by to a 20 to a 10 to a 5 to a 1. This is what your neural network looks like. Dropout layer, what dropout layer will do, they will try as much as possible to make all these neurons. So these are called neurons. All these circles are called neurons. They will try as much as possible to make your knowledge not based on a neuron. It should not be cramming. So when you do dropouts, at some intermittent times, it will randomly take out 50, maybe a particular percentage. Sometimes you can say 50%, you can say 30%, you can say 40%. It will randomly train, and when it's training, if you notice, there's no arrow coming to this place. It will not include them. In another iteration, it will include them and it will not include this one, so that you cannot be dependent on a neuron. It's making you more robust. So in a scenario where this neuron goes and gets wrong information, maybe on the field, these other ones can still say, no, this is the right thing. So it is training and not training. It is dropping some ones out randomly so that we are not dependent on a neuron that, in this kind of scenario now, if something goes wrong here, it's going to expand to all this one, bam. And it's going to expand to this one, bam. If something goes wrong in your model on the field with dropout, you will still be much more robust. Without dropout, the whole system will crumble. Am I making sense?
Yeah.
Very good. So that's what dropout layer is. Oof, sorry. This is supposed to be activation. So activation layers. How best to describe them? Activation layers. Activation layers are basically layers that makes your model non-linear. They are non-linear functions, right? So put it like this. You know, when I'm teaching you, this is my own understanding of it though. As I'm teaching you, I did not just come and say, this convolution layer, this is this layer, this is that layer. No. Right? I'm trying to say, there's Ogi, there's Moi, there's Spark. That's what activation layer does. Activation layer does, it does some approximation on your function and makes it easy for you to make sense of it. That's what it does. So there's binary step function, there's linear, there's ReLU, there's this. Many people prefer ReLU, right? But sometimes I use between ReLU and Tash. We are going to see the applications. I just want us to touch this before we continue. And then we know flattening layer. Flattening layer is layer that you take the matrix and you convert it to a single array. Right? This is what training looks like. I put this slide there in case you have to do an interview. Sometimes they can ask you some questions and you just say some of these big words and they'll be like, you're more way, you understand? So this is an example of training. So in this place, this training wants to look at distinction between a person, a bicycle, and a strawberry. So you have pictures of a person, you have labeled it as person, bicycle, labeled it as bicycle, strawberry. Now, when you are doing your training, it's called forward propagation. Now, your training will calculate an error and it will communicate back to your system. We are going to see the meaning of all these things. And it will say, your error was in the first round of training. But test. When I gave you tests, your error was so terrible, it's like 30%. It will now readjust and say, okay, let me train again. And in fact, reporting your error back is called backward propagation. Training is forward propagation. Now, it's only when we put it on the field, it's only forward propagation that we have access to. When you do your WAEC, nobody will give you correction. That's why. So this backward is like correction. Forward is like do exam. In your WAEC, on your place of work, you are just always doing exam, right? And your weight, your model is your model, right? So that's that. And some of the metrics we use are accuracy, loss, blah, blah, blah. We'll see that on 9. Some of the, don't worry. You know what? Let's move here. We'll come and see this. Let's just go to 9, right? I know. I moved too fast, Abby. So far, are there questions? Are there questions? Nobody's talking. Is it that the questions are too much or they are too few? Okay. Thank you. Thank you that there is no question.
Where to start from the question is even the problem.
Don't worry. I'm going to show you. I'm going to show you the application now. Show you the application. I know where there are likely going to be questions, and I'm going to show you. So we are going to go back to our cats and dogs. But before we go back there, this is your assignment. So detection.
So I would suggest that we do a problem in the class together before we are given an assignment back home, so that we can actually do similar or almost similar to a problem solved in the class.
Yes, I agree. We're going to do a problem together. We're problem solvers. That being said, this is your assignment. This is your assignment. If you remember beginning of the class, we talked about emotions. So you're going to create a model that will determine the emotion of a human being based on their face. And to tell us if they are angry, they are disgusted, they are fearful, they are happy, they are neutral, they are sad, or they are surprised. And if you notice per image, we have 958, 111, blah, 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 blah. So this is the assignment. Now, will it be assignment for next class? We'll see. And all of the, if you see all the images, they are in PNG. They are in PNG. So that's that. So I just wanted to get this image out of the way. So, like she said, let's do something together, right? You people are not excited. I know we are out of time. Let's see what we can do. Yes? Yes? What did someone say something? Hello? Someone said something now. Talk now. Don't be afraid.
I said excited.
Yeah, excited. Very good. Tawa, are you there? Tawa ti lọ Jamala. Tawa.
I'm here, oh, I'm here. I'm with you, sir.
Yeah. Olaleye, are you there? Nuru. We're about to start. Oh, Greg. Bolake.
Yeah.
Okay, very good, very good. So we're going to work with the data set we worked with last week, which was cats and dogs, and let's see. So now let's take what do we use? What is the first thing we use to read from folder? We're going to first list our directories and folders, right? When we list it out, then what do? We're going to go convert our path to string. Path. Iboloa. Path to string. There you are. So now let's go to the folder. I'm looking for a folder. I want to include all subfolders. I'm going to browse and go to my my downloads, and then I'm trying to look for the animals folder. If you see cat and dog, these are all PNG files, right? So I'll go to animal and I'll pick the animal folder, right? Choose. Now, if you notice, if you are doing it well, it's going to tell you that you have 1,000 files because 500 belongs to cats and 500 belongs to dog, right? I'm going to say apply. I'm going to say okay. And I'm going to read it. So if you notice, it has read all of them. It has read all of them. If you notice, there's cat. And the first 500 is cats, right? The last 500 is what? Dogs. Now, but before I continue, I want to label it. Let me label it. So this path, if you look at it, right, flow variables, they are seen as string type. I want to convert them to string, and that's why this will convert it from path to a string. If you look at it now, if you look at it, the data type is path, but now it has converted it to a string. If you look at here, it is showing as path, right? But now we have converted all the path to a string. Amen. Now, the next thing is let's label it. Let's label it. When we label, we're trying to say that, the first 500 is cat, second 500 is dog. We're trying to say that if the row index is less than or equal to what? 500, label it as what? Cat. Hence, if the row index is greater than 500, label it as what? Dog. Now, I must say something explicitly here. Forgot to say it. Ta-da. Execute. Bam. So cat. So what do I want to say? My system is not compatible with a module in 9. So it's an Apple M1 chip. And if you have any Apple M1 chip, you may not be able to get the Python integration working. So that's why I would demonstrate the workflow, but I won't be able to demonstrate a result. So it's up to you. I tried different things, it didn't work, but we'll see. On your Windows, you don't have a problem. Windows, most of you are using Windows, so there's no problem. Nobody should come and give me a did not clinical. So the next thing is to read the images. We did all these things last week, right? We need an image reader, right? It will go to all the strings that looks like a path and read all the images. And if you notice, you can see it is taking a long time because now we are dealing with image processing. It is reading all the 1,000 images from the folder. So you can see it's at 63, 65, 68, 69, 72, 80, 90, 100. And you can see that it has gone to read all the images. It's showing you cats and it's showing you what? Dog. Very good. So far, any questions? And then we can image resizer. So this image resizer is what we call our own normalization, right? Image resizer. So image resizer is like, no. This is what we use to shrink the image. All right. So we can say 0.19 so that it can be fast. 0.19. So we are shrinking along the X, Y, and Z axis. And then boom. You can see it's faster now. So I just made the image smaller. You can see the images are smaller. That's all. All right. Next thing is we want to normalize the image. So we use an image calculator. Right. Everywhere is quiet. No day. So we calculate. How do we want to calculate? Me, what I used to calculate is I'll take the image and I'll divide it by the maximum of the image. I will divide it by 255, right? I will divide it by what? 255, right? So just to normalize by. So now, because I've divided by 255, the highest number is 1. You can see that everything is now looking dark. It's looking
Can
dark.
you just going to make it grayscale? Or
What do you say?
did you just make it grayscale?
No, you are not making it grayscale. You are normalizing it. So normalizing, for example, if you look at this image now, the white is 255, right? The highest number will be 255. But now with the normalization, the highest number will be 1. 1, so that any noise, anything like, for example, all this background noise, it still has 3 channels, right? It still has 3 channels. This image still has 3 channels, but across all the channels, the highest number is 1. So it is now 0.2, 0.3, 0.005. That's why it is black, right? That's why it's black. So from here, I'm going to partition. I'm going to partition. Yes.
Excuse me, so why don't you just use an image normalizer? Why use image calculator?
No, is there?
I'm just wondering whether there's something called image normalizer.
There's image normalizer. Let's see. So it's just the same thing, right? I could have used, let's see. Let's come. So manual settings, blah blah blah. I'll check the meaning of this, but why not? Let's check. Let's see what we get. Yeah. Now this one didn't do anything. Hold on. Normalize, equalize. Manual localize. Okay. Okay. Yes. I need to just hold on. I will check this out. I will check what normalized do. The output is not supposed to be this. All right. Okay. Right. I'm going to check this and I will come back to it. If not this week, next week. Right? But for now, let's use image calculator. So partition. Now, what are the deep learning modules? Now, if you don't have deep learning, you come here, you come to extension, and you download, you just type deep learning. So we are using deep learning with Keras. You type deep learning. It's not going to show because I already installed it. You can see it. I have installed deep learning Keras, deep learning TensorFlow. So if you have just and then install and update, right? So that's that. So I'm going to go to Keras. Keras is our deep learning framework. I'm going to come to the learner. So I know this, what I want to do now will confuse a lot of people. Don't worry, I will do it. I want to confuse them. Bam. Boom. Yeah. So normalizer. Yeah.
And
Yes.
like,
Yeah.
I need guidance
Yeah.
on using this instrument.
What?
Hello.
What did you say?
I need guidance on using this environment. How, where? Because like this is my first class.
Who is talking? Who is that? Every
Okay.
person, yeah. Okay. Who knows that song?
Okay, check out.
Yeah. So yes, I'm going to paste the link so you can just download. It's called Nine Analytics. Nine Analytics is open source, free download. Yeah, you can download. This is the link to download. So I'm going to post it on the chat. Right, boom. So you have it. You can click on it and download it.
Okay. All
Yeah.
right.
So now this is all these parts. Somewhat, somehow, we are familiar with it. Even Keras Network Learner, we've seen situations where we've used the linear regression learner, logistic regression learner, polynomial regression learner. We've seen these are some of the modules we've worked with, right? So Keras Learner is we have a Keras Learner, right? We have a Keras Learner. This is deep learning. Now, how do we make our network? How do we make our network? We first need, compulsorily, we need an input layer. We need an input layer. Let's configure it. This is where you will now understand every story. All the story I've been saying, this is where you know it makes sense. Right? What's the input? Yes.
Is it like this is the normal way to do that? The partitioning, you use them. Not the last one we used to partition because you said the data set was large.
This partitioning, right? So you don't necessarily need this partitioning. You can just take this here, right? But you remember what I told you. I told you that in standard cases, you split your training and testing. When you split your training and testing, your training is now also split into training and validation. By standard, we have the training, the validation, and the testing data sets. By standard. Do you understand? We have the training, the testing, and the validation data sets. Now, what is the training data set? Like I did in your curriculum, training is what they want to use to train you, right? But and then testing is your exam and your continuous assessment. You're not supposed to see those questions. So that's this one. That's your test. Now, in your training, they're not supposed to give you classwork that will dictate your assessment in real time. They're supposed to give you classwork. They're supposed to give you assignments. They're supposed to give you examples, pop-up quiz. That's what the validation is. That's what the validation. So during training, you can see that the validation is also exposed to the learner. During training, if I want to give you pop-up quiz, I already have that part of my curriculum there. That's what this is for. Am I making sense? What happened?
Yes.
Very good. Thank you.
Okay. Another thing for the extensions, are we to download there's deep learning ONNX integration, TensorFlow integration, TensorFlow integration. Which one?
So we're not going to use Onyx. I don't think Onyx. I downloaded it because I will need it.
Okay.
I downloaded everything. So you need Keras and TensorFlow. That's the mission. What I need. Keras, TensorFlow, and deep learning extension. Because Onyx, you don't need it. So Onyx is a platform that makes it easy to transfer models. We are not there yet, right? So if you have a Keras network, but you are working with somebody that is using PyTorch, Keras is not the only network, or TensorFlow is not the only. Onyx is a way where you can transfer your deep learning in Keras, you convert it to Onyx. Onyx can now be converted to any one of them. It can be converted back to TensorFlow, it can be converted to PyTorch. So when you're talking and someone say, but it's only PyTorch we need, you say, no problem. I can do Onyx. You transform it to Onyx, and from Onyx you can put it in MATLAB and change it to PyTorch. They'll be like, okay, you know book, you too good, Jerry. Take my money.
Is there no emoji on this what's it called? This Zoho stuff. This place is dry. You should be throwing emoji.
It's emoji now. Have you seen my emoji? It's emoji.
So is it just me? I can't see cameras on that extension. This thing.
Just you.
I've searched cameras. I cannot find it.
It's just you. So I know we have. Worst case, I want us to end by 2:15. So now,
excuse me, sir.
Yes, please.
Before you continue, I can't find some of the notes, especially the ones for images, image resizer, image reader. I can't find them on.
Is this your first class?
Not my first class.
Have you watched the videos?
I've not watched some of the videos, but I watched the.
We have cached them.
You've not watched the videos. Go and watch the videos.
So now,
I knew.
If you want to, some of you, so you are probably on starter node. So you go to your preferences. I know this is Mac. This is Mac. So for Windows, it's somewhat easy. So you are on starter nodes. You're on starter nodes. Once you go to all nodes and then you click apply and close and okay.
Yeah, I'm on all nodes. I already had that.
You're on all nodes.
Yeah.
Then probably there's an extension.
Because, what I'm seeing is even a node called read images. Yours is saying image reader or something. So I can't even find
install image processing.
Image processing. Okay.
So now, just for us, we may pick up from this next week, right? But just for everything we've learned in class, for us to see it in real life. So now, our image, this is the image shape. Our image, is it 3-channeled or 1-channeled? Our image. This image, who should I call? Ogechuku. Is this image 3-channeled or 1-channeled?
3-channeled.
Yes. Are you Ogechuku?
Sorry.
No problem. So now, you already know what your image is, right? So you are going to say, my image is 150 by 150 by 3. 150 by 150 by 3. Okay.
Yes.
You run it. Now it already automatically knows. Now let's add the convolution layer. Let's add the convolution layer. You can see the 2D.
But the keras input is not connected to anything.
Because this keras learner, we already know that you already have images here now connected to it.
Yes.
It will know that this is what the image yes. So don't worry. Keras is smart, a deep learner. Now look at this.
So how did you get 150?
Am I in worry? I'm in worry. How did I get 150?
How did you get 150?
150 is the size of the image. The image is by default 150 by 150. I'm supposed to get an error. Who can tell me why I'm supposed to get an error? Nobody. I'm supposed to get an error because I have resized the image. I've shrunk it. So the keras learner is going to tell me that, hey, the image you entered here is different from the configuration I'm listing here. It's going to tell me that. Why did I tell you people?
No, it's good though. I've been confused for a long time.
So now let's configure it. Now see this convolution. See it automatically. It is telling me that I have 150 by 150 by 3. How many filters do you want? How many filters do you want? I want 64 filters. So what will be the output of my, if I want 64 filters, what will be the output of my what will be the output shape of the output of this convolution?
64.
Eh?
64.
It will be 64. God bless you. Now look at it. The kernel size is 1 by 1. I want my kernel size to be 5 by 5. Right? Did I explain stride to you?
No.
Now let me quickly explain stride. Let me quickly explain stride. What is stride? Now, if you look at this convolution has a stride of 1, a stride of 2. This convolution has a stride of 2. This convolution, where's the other one? Sorry. This convolution has a stride of 1. I'm going to explain it to you. This convolution has a stride of 1. This convolution has a stride of 2. Now, what do I mean? As I'm convolving, if I start my convolution from my how can I pause? Body. My first convolution is starting from here, right? The kernel is moving from one box to another box, side by side. One box to another box. It's not skipping. So it's moving from one and moving one step. One step, one step, one step, one step, one step, one step. My kernel is moving one step at a time. That's my stride. Stride is 1. If you come here, my kernel is jumping a box. It's jumping a box. You should jump to this place. Jump to this place. Come here. Jump to this place. You can see that it's jumping a box. You cannot see.
Yes, sir.
You can see that what? It will start from here and jump to here and jump to here. Stride here is what? Stride here is 2. Am I making sense? That's what stride is. How well you jump. If you don't jump, it's 1. You can jump 2 boxes. You can jump 3 boxes. Understand? So that's what stride is. So stride in this place is just going to go side by side by side by side. We can change it to, if you want our stride to be 2 by 2. So in some situations, if you look at this example, in this place, by the column is jumping by 1, by the row is also jumping by 1. Is skipping, is jumping sideways, is also jumping. It will jump to this place, it will skip this one, right? So you can say if you want it to be 2 by 2, it will jump both row, it will jump column. If you want it to be 2 by 1, it will jump row, but it won't jump column. It's depending on your choice. That's why I said it's design choice, right? So 2 by 2, let's apply, okay, and then boom, that's that. Do you understand the meaning why I went in there to those layers? You should know the implication of your selections here. So it's going to take in a 150 by 150. From here, the kernel is 5 by 5, the stride is 2, and the number of filters is 64. Who can tell me the output size? It's going to be 150 minus what? 64. Am I padding? No, I'm not padding. I'm not padding. Same means 2 by 2 padding. Valid means no padding. Valid means no padding. Let me see. Valid versus same padding. Valid means no padding. You get valid is without padding. Oh, same is with 1 padding. With 1 padding. Valid means no padding. Same is with padding, but it will be 1 by 1. Right? So that's beautiful. Yeah. So this padding. So I want you to understand. That's why as much as possible. See the activation function. We have ReLU, we have Tanch, we have this. I think the only thing I've not explained to you here is dilation. Right. So let's continue. So that's about that. Reset. Let's go. Good. So the next thing is pooling layer. Pooling layer. Pooling layer. I hope you know there is 1D pooling and there's 2D pooling. Why we are using 2D is because our image is in 2 dimensions. Our image is in 2 dimensions. right? So if all those data set that we've worked with for housing for this, if I was going to use convolution, it would be 1D convolution because images are not in 1D. And those data sets are not in 1D. What is pooling layer? In pooling layer, it is size. Padding is valid. You can also pad pooling layer 2 by 2. Let me see. Pool size. Blah, blah, blah. I'm trying to see. There should be a place where. So I'm assuming by default they are using max pooling. They are using max pooling by default. So tada. So we have done that. Then the next thing is we can do the same thing. Yes. Somebody is saying.
Excuse me, sir.
Yes.
Yeah, for the max and pooling, so yeah, max and 73 by 73. I think it was set at 150.
What do you say?
For the Keras max pooling, showing 73 by 73.
Where? Yeah.
Like configuration, yes.
Yes, now. That's what we are going to get out. That's what is entering. So if we do the formula, so if you come here, if you come to this place and we do 150 minus what? 150 minus 5, that's what?
64.
150 minus 5 is 64.
5.
Eh?
No, sorry. I think you said I want to see my 64.
145.
150 minus 5.
145.
150 minus 5 divided by 2 is what? 72.5 plus 1 is what? 73. And it will skip, it won't take the other one. So that's why you're getting 73. So if you can see, it's 73 by 73 by what? 64. Why is it 64? Because the number of filters we are using here is 64. That's why it's not good to lie. So I just want to parent and we just cast it.
This makes sense for explanation.
What do you say?
Makes sense.
Yes. Makes sense. So now we are just using conv2d. Now, if you look at, I'm convolving the pooled output, and I'm saying that because I've put 64, let me say maybe 32. This is where design choice comes in. So in the first one, I use 5. Let me use 3 by 3. In the first one, I use try. Let me use 1 by 1. This is where design choice comes in. If you now have concrete knowledge of, of what convolution is, what pooling does, you will know that this is the image, this is the type of image, this is the feature. This is where you now have to read. There's no time for me to tell you that this is the best for this. Do you understand? So the next pooling, what is he receiving? It already knows what he's receiving. It's receiving 70. But now there's a problem. So many of us, and this is a problem with many machine learning engineers, many of us just think of the software. We don't think of the hardware. In the computer, you can create a network that is as big as an aeroplane, crayfish. You can do it. You understand? But on the hardware, so if you look at this place was 150 by 150. As I'm getting here, it is 150. But as I'm getting here, it is 73. Right? Between here and here, guess what it is? 70. So those computation, they need computation, but they didn't subsample down. Right? They'll be taking the resources, but they'll be doing resources on still big matrices. Right? So the output of this would have shrunk it down to maybe from 70, maybe 30 something. So I've shrunk it down to 30 something. Let's see. Yeah. So the input that this one will receive by will now be what? It will be what? Yeah, 69. How the hell is it 69? Oh, it's 69 because I reduced this. Hold on, sorry. Let's reduce this. So 5,5. Right. Good. Now your pool, you can also make it what? Instead of it to be 2 by 2, it can be 3 by 3. And then by the time I run this, it's still receiving 66 by 66. Adari. No problem.
Where are we convulsing? How are we doing the convulsion and the pulling too many times?
It doesn't, like I said, it's design choice. There are many. So let me show you an example so that you know. Let's say the first network that opened people's eyes in 1990 is called Linet. Linet, let's see it. Now look at how Linet was. Linet was convolution pulling, then dense layer. That's it. Now let's go to something like AlexNet. AlexNet was the first one that did computer vision so well that people loved it. This is what the structure looks like. This is what the structure looks like. You should be able to interpret this. It had a convolution, a max pulling, a convolution, a max pulling, a convolution, a convolution, a convolution, pulling, then dense, softmax. You can repeat it as much as you want. See, convolution with activation of ReLU and the max pull, convolution, ReLU. You now know the meaning of these layers. You now know the meaning of these layers. So these are standard practices. You can do it. It just depends on the memory you want or the desired accuracy you want. So you can see people do convolution pulling as much as possible. Then they flatten it and they put it to the dense layer, and that's it. Am I making sense? See this one. Input, conv1, pull 1, conv2, pull 2, conv3, conv4, conv5, pull 3. Is it me? I will have put conv pull. This person put conv. It's fine.
Sam,
yes.
Is it okay? The intention is to get the right model that will predict right. Like, what's really the intention of having so many, like, going on and on and on and on? What are we?
What's the intention of going on and on? You want to get the right intelligence. So, and that's the thing about intelligence, right? It's not like a building that is already, an architect already made it and they have done it. You know the limits. Or mobility fence, you know where the fence should be, the foundation should be. No, this is not like that. If you look at your secondary school or your primary school, and it's not a thing on them, it's not all of you. Sorry. So it's not all of you in class, like take from your kindergarten. It's not all of you that like maths the same way. It's not all of you that like this the same way. This is, let's put it like this. This is the way the machine learning engineer is trying to place the knowledge of the features systematically in the student's brain so that it makes sense. This is just the sequence. So this one is saying that I will give you the raw image. Maybe, for example, we are just going to be like, hey, take this simultaneous equation. We are going to give a 5-year-old. Take this simultaneous equation and go and solve it. I don't know it. Just do anything you write. He's going to write anything and he will come back with this learner is going to come out with a very low score. When you come out with a low score, okay, we will now ask it, why did you do it like this? Should you do it like this? Is it okay? Let me show you an example. You do this, you do this, you do this. So this is the sequence. Now, there are some math teachers that are better than some math teachers, right? That's where there are some machine learning engineers that are better than some machine learning engineers. So this is where you, as a machine learning engineer, you will come and study different structures. You come and study different structures, like this efficient nets, right? This efficient net, right? You come and study different structures. There was a time that efficient net was the best model that ever existed on Earth. But now it has moved. They've moved to transformers. Just like, for example, there's a time now that ChatGPT is the best ChatGPT ever. But I'm telling you, in next 1 or 2 years, people will not be talking about ChatGPT again. It will be another type of GPT. So someone like you now, as an engineer, you'll be like, they've given me something. What is the thing they gave me? They gave me to go and do a model that can identify traffic lights. What's the first thing I will come and do? machine learning model for traffic lights. Let me look at all the structures and shapes state-of-the-art people have done, and let me pick up from there. You understand machine learning for traffic lights? Because it will be there. Traffic light, right? It will be there. Somebody has done it. He has done a research on it. What was the structure he used? He did input. What type of layer? LSTM. He used LSTM, drop out this. Why did he use LSTM? Those are questions you ask. What is an LSTM layer? This is where as a designer. So by the time you are coming to your boss, like, hey, you know, this person used LSTM, so I chose a design choice of LSTM. Someone can now use convolution if that works for them, but you can't just enter a project blindly. You can't enter a project blindly. It has to be systematic. Shorty, maybe they've not done it before, right? Have they done something similar to it? What did they use? What's the concept they used? Am I making sense? For example, there was a time at work I had to read up concept from Tesla, what their machine learning engineers did in Tesla. I had to amend and make a copy of that project for what I did at work in my own company. Do you understand what I'm saying? So everything is design choice. I chose what they did. I didn't use exactly. I could have used exactly, but if I use exactly, it won't apply to what I wanted to use it for. But it was a foundation of which I used it for. So you asking me the question, why is it convolution pooling? How many convolution? Can we write convolution pooling from here to Sabo? That's your choice. This is now what will distinguish you from a good machine learning engineer from a bad one. Am I making sense? It is Orojo. Yeah, nobody's talking.
Yes,
What do you say?
Yes.
So if you just ever downloaded the Cohort extension to tell me how they did it, because I can't still find it.
Oh, see, you just come in now. You will search for Kera, so you search for deep learning. Deep learning is what you find. So let's continue from convolution. You will now use flattening. The flattening layer. The flattening layer will take this one and bring it here again. And then let's look at the parameters for the flattening layer. If you see it, the flattening layer the length of the flattening layer will be 63 times 63 times 32. Because flattening layer will convert everything to one single line. So let's now take a dense layer. Again. Look at what the input is. You can see it. 127,000. If you multiply 63 by 63 by 32, it will give you that. It's coming from a flattening layer, and this is it. 127,000, right? And then so this dense layer, the output, I'm taking it to 1, but I want an intermediary. I want to take it to, from 127,000, I want to take it to 800. And then from 800, I want to take it to 1. Right? And this will now come and take this. Boom. And lo and behold, we have our first machine learning project. Now, this is the problem I have. Hold on. Can you see? Can you see the error he gave me? He said input cannot be opened because the input is seen does not have is missing or has no columns. Hold on. That's not the error I'm supposed to get. But let's see. Okay. It's partition is not partitioning. Okay. Let's see. Bam. So I'm going to get an error now. Why am I going to? You can see it's training. It's going to give me an error because of my configuration. But you can see it was training. It's going to give me an error because of my configuration. So the type of chip I have on my computer they've not created one that is suitable for it. So that's why. But that being said, on your Windows laptop, you are supposed to be fine. There's no excuse why You have not done it. Let me look at some
I have
people.
an M1 mark.
Yeah?
I have an M1 mark.
You have an error on Mac.
M1. M1.
You mean you and I are the same. Yeah. But it doesn't stop you from trying to research and solve the error. Solve the error. Make sure you solve it for me. That's your assignment. Go and solve the error. Abimbola. Abimbola, are you there? Abimbola, maybe some people I'm sure some people are sleeping on this lesson. Anna.
It is well.
Abimbola, you raised up your hand.
Jesus have mercy. Please God.
Annie, what happened? Umana Anika.
Yes, that's me.
I thought you raised up your hand.
No.
Okay.
No, sorry, it was an error.
No. Abimbola, don't worry. It's you I want to talk to. Are you there?
Yeah, yeah.
What? Any question from me?
No, not yet.
So you understand everything?
No, but like I'll go back and look at it.
No, right now, tell me what you don't understand so that we can shed light on it. All of us together as a team. The new force of machine learning in Africa.
Nothing for now. I don't have any question.
You don't have any question. Next class, I'm writing your name down now.
Yeah, I have question.
Oh, you don't want me to call your name? Who is the person that I have? Who has question?
Ogechi.
Oh, yes. Okay. How are you? First things first, you came late to the class. I can see from the time under your name, you came late. But it's fine. It's fine. Oh, yeah, what's your question?
My question is first, why are it looks like a film? So for me, what does when you started from the beginning? So what does like I don't know, what does all those means? All those things looks like those cards that children put together like playing puzzles. Like, so I don't know. What do they mean? I don't understand.
I'm trying to get you the class, the AIF class link, but I'm going to send you the link and put all the recordings there. All right. So yes. So you said that all the images is like film to you.
Yes.
It's like film to you. And that is fine.
Yeah.
It's fine. Every film, when you start it safe, you be like, that's why every film, when you start, why did that guy shoot that guy? Why did he kick him? What's the name of the actor? Everything, every venture we start with, we start from the unknown. I want you to take it like that. I'm sure that in the next 3 lessons, Ogechukwu, it's you that will be teaching me, you are wrong. You are wrong now. You are wrong. Don't worry. That's how you would have understand.
Amen.
You understand? So don't worry. What I want you to do is, first things first, you've not downloaded 9. Second is there are some classwork assignments that some people have built up all to, it's foundational. Now, I'm telling you this because it looks rough, but by the time you do what all those people have done, it will just automatically make sense. I know now you have questions for me. You just don't know what to ask.
Is that where we can be on WhatsApp? Like,
we are on WhatsApp, we are on Telegram, we're everywhere.
No, okay, so on WhatsApp, so who are the genius? Come on, I can.
Josephine, Adoga, Damilola, one more week back. Abimbola K, Anna Duncan, Greg.
Let's come and learn from your feet, though.
This is group discussion now. Do group discussion.
Yes, this is boring. Nobody is talking. Everybody's doing professor. Please don't be professor. Share your knowledge with us.
They want to carry first. Don't want them to carry first. Don't worry, right? So what I want you to do is, this is your first class, right? And I think in the past 2 weeks, the Telegram has been very well engaged. People have been dropping their classwork, their assignments, their questions. So don't worry, join the Telegram group, download 9, go through the videos, and you first see, just go through the videos, go through the exercises, everything is fine, right? People are very well engaged on the group, so don't worry. I will post Telegram group and the classwork, right, on the group. So no problem. Any other questions? Anna has slept off.
Please, I have a question.
Who has a question?
Please, I have a question.
Yes, please.
Yes, please. Okay, I actually want to plead with you that if you can make the video available this night, like this evening, because I'm confused.
The last one I made it available, sir. Don't worry.
Yes.
Yeah,
No,
are you on
but
the Telegram?
Yes, I am.
Okay.
For the chemistry flattening node, so it shows 32, and I'm thinking that it's like the 64.
We can't hear you.
How did you get that 32? Can you hear me?
Can't hear you clearly.
I just for the Kera's flattening this thing that we did. So I noticed that it brought it down to 32. And you were trying to give us the logic of why it was 32, but I didn't understand.
About this layer, right?
Yes.
Now, if you look at the layer, it brought it down to 127,000. 127,000. Now, how did they get 127,000? If you look at this, is 63 times 63 times 32. If we come here and we do 63 times 63 times what? 32. 127,008. That's how they got. That's how. Yes.
How did you get that 32?
How did you get that 32? They got that 32 from the pooling layer. If you look at the pooling layer, it is 64 by 64 by 22. The channel, you understand? So after pooling perform this pooling operation, right? Yeah. Who are we? Who is talking? Okay. So any questions so far? Any questions?
So why did we set our dense layer to 800?
Oh, it's design choice, so you can do 80,000. It's design choice. You understand? So now I think what I need to tell you, do you know what the dense layer does? Yes, that's why you're asking that question.
No, I don't know what it does.
Dense layer machine learning. Dense layer is like your brain. Dense layer is the opolo in the brain. So let me give you an example of how your brain works, of how our brain works. So our brain actually is an electrical system. Our brain, like this, is an electrical system. Now, for example, some of you have met me, you have seen my face. Of course, you don't know my eyes, but you have seen my face. And because you have seen my face, the first day you saw my face, you attach me, the concept of me, to an event. The event is on Saturday, right? Yes. You have a name to the concept of me. Now that concept of me, you have not created a map, another neuron. Immediately, every new memory creates a new brain. Now that you are not different concept to it. Concept of 9. You see that sometimes when you remember in the future, I remember 9 more. Dr. T used to teach us. Once you remember, you remember Dr. T. You've now used some data sets. You've used things. Some people are distracted. Let me see. So the concept of me has mapped a lot of things to it. That's the way this machine learning works, right? It creates neurons. It creates neurons of far. It now creates different weights of memories around the neuron. So that when you remember one, you can remember when you see an attribute of one. For example, if I say Nigeria, Right now, the neurons that has mapped to Nigeria in my head is Nigeria. I am chosen. I am chosen. Lion, tiger, or Nigeria, Tinubu, interest rate. Those are things that has mapped around the neuron of Nigeria. So once you will forget that, you will go and check and refresh that neuron, and someone's, you understand? If I think of Ghana, Black Stars of Ghana, you understand? Those neurons. So your brain is an electrical database, creating relational database, creating relations between events. Then depending on how large the event is, it's a neuron that it has now mapped and mapped and mapped and mapped and mapped. If you notice, I hope you know that elephants don't forget anything from their baby. Do you know that? Hello? Can you hear me?
Yes.
Yes, we heard you. Elephants don't forget anything. How come?
Because of their
I've never heard of that.
Sorry. They forget, but they have a very remarkable memory because their brain, you can see it. Why? Because of their spatial memory. Their brain, the database for their brain can contain whatever we can contain, maybe 8 petabytes. Do you understand? Like they can like you've not seen the story of an elephant that went to attack a woman. The woman, just check it. It was in India. You know India. I'm sorry that I'm digressing. In India, a woman helped poachers to kidnap the baby of an elephant. Right? The elephant mourned and remembered that woman. He remembered the woman that it went to kill the woman. Like it went to the house with the woman and killed the woman. When they were burying the woman, the elephant went and scattered the burial. That's how vengeful they are. Because they don't forget.
That's a spiritual elephant.
It's not spiritual, it's how they are. It's how they are. That's biology. They have memory. So in humans' head, we humans, we are also like that too. Every event we create a neuron. When we create a neuron, we map it to another neuron, and there's a bridge to that neuron. When you think of maths, I'm very sure when you think of your secondary school maths, you think of your secondary school teacher. When you think of your teacher, immediately you think of your principal, and you now think of all those good old days. It's because those memories are mapped in the same area. So that's how dense layers work. That's how they work, right? We are creating mapping. So for example, we are saying dog. I'm now creating different neurons. Someone's 2 neurons is enough, someone's 3 neurons is enough, someone's 4 neurons is enough, someone's 10 neurons is enough. But when this is dog, this is all the things you should look at to pinpoint that this is a dog. This is all the things you should pinpoint that this is a cat. That's what dense layer is. And that is what we are trying to do. So all these ones, it has used it to extract the feature up to this place. Up to this place, it has extracted the feature that makes a dog, a cat, a cat. Now, it is now creating events in its own brain to say that, I'm looking at this. It's making meow sound. It has whiskers. It is sneaking. Is this a cat or a dog? It's a cat. That's what this is. So you can now decide to make it 5, to make it 8, to make it 10. Depend on you, the quantity of your dense layers, the quantity of your convolution layers, the quantity of your pooling layers is totally dependent on you, the designer. But you need to know how they work for you to know the quantity they have. And you also need to know the consequence of the quantities. Because the more you put, the more the hardware resources you need.
Okay.
The more you put, the more. So that's why you need. So people can. If not, people will just put and you just take it. Or they'll be like, where will we put this one? This one is too. Is maybe they give you megabytes. You are bringing gigabyte model. No matter how good it is useless for what you want to use it for.
Oh, wow.
Do you understand what I'm saying? So even if it's giving you 100% accuracy, if it's useless, it's useless. Making sense?
Okay.
So I think this is a good place to stop. Sorry that it went over, but I feel it was necessary. I know there are questions flying helter skelter. People are in their head, and the concept is in their head. Please, we know from tomorrow. I know the concept I gave you, right? Okay. I will know if the next time you open it is on Saturday. I know. Because there are some questions you are supposed to come at me with. I'm your doctor. I'm the one that is diagnosing your machine learning sickness. I will know if you use the paracetamol or the fancy. I will know if you use it. Hello. Okay, Chuku. Okay, Chuku. Okay. Okay, Chuku.
I have a side question, sir.
What's the question?
I've seen Linet. I've seen AlexNet. When are we having ToluNet?
Me. Let me now use this to brag. Let me use this to brag. So me, what I studied was how to train this intelligence and how to fool them. How to turn your deep, intelligent engine into a dullard. So if you want to read more about my research, you come to Google Scholar. When you come to Google Scholar, you just search for my name. So in my name, I designed Trojan attacks. I attack intelligent engines, right? I attack this deep learning. Whatever you think that you have trained that is intelligent, or I try to fool them, right? Some of my attacks are called SOA.
Interesting.
So for example, this person, I saw this person. This person just used some of my research and called it the evil within. The evil within, and he used my name. So for some of you that want to do your grad school, sorry, wait, what's my name? This is my name, Sha. So this is my name. So on the paper, I am 83. I am 83. So this is where he used how I use the attack to attack memories on a machine learning model on a computer. So I did not go and design intelligence. I went to design what will make an intelligent person a dullard. So if you're in secondary school, I'm that boy that will not make you pass in machine learning.
How you will fail.
We will repeat together. That's what I mean. You understand what I mean? So,
yeah, really first students.
And why they need us is, if you notice, recently, this is very recent. This has nothing to do with machine learning, but apparently, like Nigeria, we used to import things. So some countries in the Middle East imported a pager, all this pager that they used to use to page themselves. They imported it from an international manufacturer, but those manufacturers have not confirmed the story. So I mean, misuse some details. They say those manufacturers are linked to Israel or Afghanistan or one country like that. Apparently, out of those manufacturers, they put randomly some explosive in those pagers. So when you take your pager and you check it, the thing will just explode. Boom. And they've now put a time Trojan on it. So some people, over 3,000 people, lost their eyes, their fingers, their this, that, all of a sudden across the country. Now, someone like me, in my own research, what I did was that I found a way to fool an intelligent machine. I was not like, for you to fool the intelligent machine, you need X, Y, Z. How can we defend against someone that is trying to fool the machine? So, in other words, how can we make it much more robust that if someone tries to fool it, the machine will catch it? That's what I did.
Okay.
So I took the role of the attacker and then the role of the defender. Long and short.
Okay, so in this case, hello.
What did you say?
Hello.
Yes.
So in this case now that you painted in this story, so people those bombs. So how can you use intelligence to actually? I felt that your research could also be a way to dull those. Is there a way your research can dull any attack that
Wait,
is
so
harmful to humans, or
is it like me as an attacker or me as a defender? As an attacker, I'm trying to dull the intelligence. As a defender, I'm trying to protect the attack. You understand what I mean?
so if you you said attacker and defender, right? Yes. Now, so attacker, you said you dull, right?
Yes.
Yes. So if they have a bomb on the pager, can your intelligence, which is an attacker, get to those bombs and dull their, I don't know, is it a way of
So now I'm very sure now those companies will put things in place to say, if we're getting pager, these are the types of pagers that cause explosions. These are the type of pager that do not cause explosion. You give me those attributes, I can create a machine learning that will tell you that pager bad, good, and it can be on a filter and it will be separating it.
Okay. I think that's a good option. I think that's a good option. But what if you are not giving those parameters? How do you design it?
No, it has happened already. What has happened? They've exploded. So all I would do is I will write to the government of my country and say, hey, give me attributes of this manufacturer. The country it came from, the manufacturer, the weight, because an ordinary paper they weigh less than the one with explosion. The weight of the paper. What is this? What is that? When it explodes, video what's it? What's this? I take all those and I give it to a machine learning. It will find new ones to say explosive, non-explosive.
That's true.
Makes sense? Did I answer your question?
Yes.
So this is how you, as a machine learning person, let me tell you something. There's no place where human intelligence is that machine learning does not have a place. Everywhere where you are using a human brain, machine learning can play a role there. It depends on how you think and how the idea you come and how you want to solve your problem.
Yes.
That's interesting.
So I want you to go through stuff. You're already entering the realm of Alagbara. You are no more. If somebody come and say, machine learning, I'm 0 level, it's a lie. You're already intermediate. You're entering the realm of Alagbara. It now depends on how well some of you will stop and forget and say, procrastinate. Some of you will say you are listening to it while you are taking a walk. Some of you will say, some the podcast, Some of you will say this and some of you will say that. But some of you will be like, hey, Dr. Tonu, I saw this on Kego. Can we do it? Why can't we do it? Hey, this, and you this. And also you'll be better than me, Seth. Oh my God. Class was the class together. Boom. It's your choice. My joy and my prayer is that in the next few months, you people will be posting on LinkedIn about the new machine learning algorithm that came out and the advice you have for Elon Musk and how you are and what you feel and the direction you're going. Hey, some of you are laughing. Some of you are saying amen. Some are laughing. Some are saying
amen. Amen.
Is it not whiskey that is hanging out with all the big boys now? Whiskey, don't you leg back on? It's possible. You know how you do it. Call on Falu Barika. You get work of our hands. So, any other?
Thank you so much.
Any other question?
Yeah, doctor.
Yes.
Yeah, thank you. Thank you for your time and the inspiration. It's good to hear that you had a very interesting topic for your PhD dissertation. That's very interesting. And thank you for what you have been doing. What I wanted to say, somebody has raised it, just dropping the videos and the recordings as like almost immediately, and someone has actually raised that, and you have responded to that. Thank you so much.
Immediately we stop this meeting like this, I will drop a message on Telegram and say, you know, is down. I promise.
Yeah, that's okay. Thank you so much, and
you're welcome. You're welcome.
Thank you for your time.
Yeah,
I love your PhD thesis. Actually,
no problem.
I've just gone through it.
Please, I'm out of school. If anybody has, have an idea on problems, want to brainstorm, please. So far, you put my name as one of the authors. Fine.
We might have to do something together. Seriously, we'll communicate across to you.
No problem. No problem. Yes. So I hope with these few words of mine, I've been able to convince you and not confuse you.
Not confuse us.
That you can do way more than what you think you can. You can do way more. Sombo, you're raising up your hand. So no problem. Bolanle, you joined 9 minutes ago.
Yes, can you hear me? Dr. Otolu?
Yes, I can hear you.
Yes, I said.
You said what? Sumbo.
Yes, my network is actually lagging. I'm speaking. I said, can you please say, drop the Telegram link on WhatsApp group? I'm not on the Telegram link. Group, and I think I'm missing out.
Telegram.
I'm missing out.
I will put it there. No problem.
All right, thank you, sir.
You're welcome. So, I think, is that all the questions? Okay. So, thank you very much, everyone. I want to wish everyone a lovely weekend. Please make sure you practice. It's a difficult concept, but step by step, it becomes easier. Right? So, thank you very much. Thank you, everyone. Right? So, I will talk to you next week. Make sure you practice. I will know if you don't practice. Right? And let me even say the order in which I will ask the questions. I will first, Ogechi, if you don't join my next class, don't ask any question again, you are banished. Ogechuku is the first person I will ask question that I will look out for. Then Sumbo, second person. Josephine that is to come late, no problem. Then Greg, I will ask Greg. Thomas missed half of the class, but that's fine. I will ask Thomas too. Right? Ogogo did not join today's class. Ogogo did not join. Francis, no problem. Josephine, I'm assigning.
Ogogo is on set.
Ogogo is where?
He's on set.
He's on set. What happened? He's doing video.
He didn't. I'm just joking.
So Josephine, I'm going to attach you to teach Ogogo everything that you have learned in class. Anna Duncan, we should see you next class.
Hey, sir, I think I have an idea. Is there a way we can have, like, maybe we should do study mates together? Like, probably if we have assignments, we work by 3s or by 4s.
Please feel free. In short, I was expecting, I just did not want to plan the idea. I was expecting that someone will say that, guys, this is a Google link. Dr. Tolu, if you can join. This is a Google Meet. I will just wait there for the first 15 minutes. If anybody wants to join me, let's just talk through these concepts. Let me spectate and let me see someone teach what I'm teaching. And it's also a thing where you can drop stuff on Telegram and create a subgroup. You can just ask the admin on Telegram, hey, can we create subgroup or study groups? And some people will join, and you can close the group when you have reached the limits. And another person should go and join another group. Do you get? Like, please, we don't want to force you to study, right? But we want you to study. It's a desire of ours, all right? But we don't want to plant it and across your neck, right? Anna, you raised up your hand. Anna Duncan, we are all waiting to hear you. Anna is not talking again. Anna, are you still in the bus? Because you were in the bus.
So I've been talking since you said that I was not in class. I thought I was I was in class.
I know you were in the bus before. You were talking to all of us. That's why I said, have you gotten home now?
No, I'm in the bus, but I've been in class.
Okay, no problem. Anyway, safe trip, safe. Please, let's be seeing you on the Telegram group. So
I'm on the Telegram group, but I can't send the message. That's why.
Okay. I think this is a good place to stop, right? So thank you very much, everyone. Thank you, Eshegon. So I will talk to everybody later. Take care of yourselves and have a lovely weekend. Take care. Bye-bye.
Thank you,
Bye.
sir.
Thank you.
Thank you.